Hi everyone. In today's video, we are going to study about the third loader scheme, that is absolute loader. In the last videos, we have already discussed about the first two loading schemes, that is compile and go loader scheme and general loading scheme. Let's see in detail about absolute loader. Absolute loader means it is the simplest type of loading scheme and it follows the general loading scheme. Why it is calling it is the simplest loader scheme means when I explained you about the functions of loader, I explained you the main four functions of the loader are allocation, relocation, linking and loading. Absolute loader is only can perform the loading function. That's why it is called, it is a simplest type of loader scheme and it also follows the general loading scheme. So we have already seen how does the general loading scheme. We have the source program. We will give the source program as the input to the assembler. Assembler will output the machine language translation of the source program. And what is the output of the assembler? It will not directly stored into the memory. Instead of that, it will be punched on the card. This coded information is called object deck and object deck or object program. So once the object program is ready, whenever we want to execute that particular object program, only that time we will be loading the corresponding object program into the memory by the loader. And the to which address we have to load this object program will be clearly mentioned in the assembler by the programmer. So that is the main feature of the absolute loader. Absolute loader is the simplest type, which means it can only perform the loading function. It cannot perform linking, loading and relocation. Okay, sorry, it cannot perform relocation and linking. Okay, then we told you the output of the assembler will be punched on the object card, and this is called object deck or object program. And this object program will be received by the absolute loader and it will be loaded into the memory address which is specified by the programmer in the assembler. So whatever object program we want to execute, to which address we have to store this object program in the memory will be clearly mentioned in the assembler program by the programmer. So here it is very clear that allocation and linking will be performed by the programmer, because the address to which we have to store it is mentioning by the programmer. So here allocation and linking will be performing by the programmer and a relocation will be performing by assembler. So the only function of the absolute loader here is loading. Why it is called absolute means whatever address we have mentioned in the program, to that absolute address only that particular loader will load the program. So whatever absolute address mentioned in the assembler program by the programmer, absolute loader will load the object program only exactly into that particular absolute address. That's why it is called absolute loader. So it is the simplest loader and it follows the general loading scheme, which means the output of the assembler will be punched on the card, that is called object deck, and this object deck will be received by the absolute loader and it will be loaded into the memory, the address specified by the assembler, specified by the programmer in the assembler. So here the function of the absolute loader is loading the object program into the absolute address. Absolute address means the exact address mentioned in the assembler program by the programmer, not anywhere else. So it can only perform the loading task. You can see as an example here, we have two programs. One is main program and another one is the one sub program, that is SQRT. Okay, so this is the program, and in the program it is clearly mentioned that when we are loading the main program into the memory, it has to start in the address 100, and in the subroutine SQRT program, it has clearly mentioned the starting address of the subroutine program is 400. So this means 100 is the absolute address for the main program and 400 is the absolute address for storing the SQRT subroutine in the memory. Okay, so whenever the absolute loader is loading this main program, object program and the subroutine object program into the memory, it has to exactly store into the absolute address 100 for the main program and SQRT has to store in the absolute address 400. That's why it is called absolute loader. Whatever absolute address mentioned in the program, absolute loader will load the main object program and the subroutine object program exactly into that particular absolute address, not anywhere else. That's why it is called absolute address, storing object program into the absolute address mentioned by the programmer in the assembler program. Now we are moving on to the design of an absolute loader. Design of an absolute loader mainly includes the algorithm. Okay, so before starting, we have to understand. Here, I told you whatever be the output of the assembler, that means it will be stored on the card. It is called object deck or object program. So object deck will be containing a set of cards. Okay, so an absolute loader will read each card from the object deck or the object program and it will load into the absolute locations specified by the assembler. I'll repeat. Here, absolute loader will receive input as the object deck, where object deck contains many other cards. Okay, so absolute loader has to read one card by card from the object deck or object program and load each card into the memory in the address, absolute address specified by the assembler. Okay, so whenever the absolute loader is loading object deck into the core memory, object deck has to convey two types of information to the loader. Okay, so object deck must communicate two types of information from the assembler to the loader. Those two informations are: first information, the converted machine language instruction and to which address we have to store that. That is the first information conveying by object program or the object deck to the absolute loader. That is, what is the converted machine language instruction and to which address this particular machine language instruction has to be loaded in the memory. This is the first information conveying by object deck to the absolute loader. Another one is the entry point of the program, which means once we have successfully loaded the output of the assembler into the address specified by the assembler, we have to start the execution of the program. To start the execution of the program, we need to know what is the starting address of the program. So the second information conveying by object deck is the starting point or entry point of the program. What is the starting address of the first instruction of the program? So understand, whenever object deck is loading by the absolute loader into the memory, object deck must convey two informations to the absolute loader. The first one is the output of the assembler, that is machine language instructions, and the address to which we have to load this machine language instructions. And the second one is what is the starting address of the program or entry point of the program. Okay, so whenever we are talking about object program or object deck, basically it contains the three cards, that is header records or header card, then text cards or text records, and transfer cards or end record. Okay, so each object program will be containing three records or basically three types of cards. One is header card or header record, second one text card or text record, and the third one transfer card or end record. Okay, so here the header record will be telling what is the name of your object program and what is the length of that object program. And we have two more types cards, that is text card and transfer card. Text card will be containing the converted machine language instructions and the data to be loaded into the memory, and the information and the address also to store that particular converted instructions into the memory. Transfer cards or end records will be holding the entry point of the program, so we can initiate the execution of the program. So we were talking about design of an absolute loader. So absolute loader receives the object deck and it will be loading into the memory specified by the address specified by the address specified by the to the address specified by the programmer in the assembler. Okay, then each object deck will be containing set of cards. So absolute loader has to read each card by card and it has to load into the memory to the absolute location specified in the assembler program. Okay, so each time when a object deck has to convey two information to the loader, absolute loader, that is the first information is what is the output or converted machine language instruction and to which address we have to store this converted machine language instructions or the output of the assembler. And the second information is what is the starting point of your program or what is the starting address of the program. So each object deck has to convey these two information into the absolute loader. Okay, now we'll see how actually it is working. Okay, each object deck or object program basically contains three types of records or cards. One is header card or header record. That particular card is the first one. It will be containing name of the object program and the total length of that particular object program. Then the second one is the text card. This particular text card or text record will be containing the output of your assembler and to the address to which we have to store this instructions as well as the data for executing this instructions. Okay, then third type of card is transfer card or end record. It will be the last record of your object program. It tells what is the starting point of the program. That means once we finish with the object program, last line will be end record or the transfer card. It will tell starting address of the program. So once we loaded the object program into the memory, the transfer card will tell what is the starting point of the program, so that we can transfer the control to the starting point of the program and we can initiate our execution. Now we are going to see what is the format of the text card and transfer card. So this is the format of the text card. Text card means what? It is the card in the object program. It contains the converted machine language instructions and data as well as to which address we have to store this. Each text card will be containing 80 columns, whereas each column contains 1 byte of information. Now we'll see what is there in each column. So the first column tells the type of the card. If that value equal to 0, which means this particular card is a text card. That means this card contains the converted machine language instructions and data to be loaded. So the first column tells the type of the card. If it is 0, which means it is a text record or text card. Then the second column gives the total length of the information available in the text card. How many number of bytes are available in this particular text card. Then 3 to 5 columns will be giving. That means I told you text card will be containing the output of the assembler, that is the machine language instructions, to which address we have to load these output of the assembler. That address of that information will be given here. That means to which address we have to load our output of the assembler and data. Okay, so that starting address of the memory will be given by this 3 to 5 columns, and 6 to 7 columns of the text card is usually empty. It is usually using for validity checking. Then 8 to 72 columns are actually containing the converted machine language instructions and data to be loaded into the memory. So the real data and the converted machine language instructions are occupying in the columns from 8 to 72. Then this particular data will be loaded in the address specified in the 3 to 5 columns. Then 73 to 80 columns will be specifying the cards sequence number. Like this, we will be having many cards. So what is the sequence number? So it will be specified in the 73 to 80 columns. So this is the text card. It will be containing the converted machine language instructions and data, as well as to which address we have to load this instructions in the memory. So this is the format of the text card. It will be containing 80 columns. The first column tells the type of the card. If it is 0, which means it is a text card. Second column, gives the total number of bytes available in the text card. Then 3 to 5 columns specify to which address we have to store this output of the assembler and data. So that is the 3 to 5 columns. Then 6 to 7 columns, usually it is empty. It is using for validity checking. 8 to 78 columns are really containing our output of the assembler, that is the converted machine language instructions and data for its execution. Then 73 to 80 columns will be containing the sequence numbers of the cards. Then the next type of cards in the object programs are transfer cards. Okay, transfer cards means it doesn't contain any data. It only tells the, once we loaded the program into the memory object program, what is the starting address of that, or what is the address of the first line of program in the memory. So transfer card will contain only the entry point of the program, that is the address of the first instruction of the program it is using to initiate our execution. So this is the format of our transfer card. Transfer card also containing 80 columns. Each column contains 1 byte of information. Let's see each column data. The first column tells the card type. If the card type is 1, which means what? It is a transfer card or end record. Okay. Then the second column tells count equal to 0, which means here we are not storing any instructions or data. It is using to only tell the starting address. So the length of the data available in cards will be 0. Okay. Then 3 to 5 columns will be telling address of the entry point. This is nothing but what is the address of the first line of program, okay, in the memory. So this is the starting address of our program. 60 to 78, 72 columns will be usually empty. As I told you, it is using for validity checking. Then 73 to 80, like this, we will be having many records and many cards. And this 73 to 80 columns will specify the card sequence numbers. So this is the structure of the text card and transfer card. Apart from these two cards, we will be having one more card or record, that is header record in the object program, that is containing the object program name and total length of the object program. So these are the things involved in the object program. Now we are going to see the algorithm for algorithm for the absolute loader. So this algorithm says how an absolute loader is reading data from the object program and loading into the memory. So each and every object program will be containing 3 records, that is header record, text record, and a transfer record or end record. Header record is containing the name of the object program and the total length of the object program. And the text record will be containing the output of the assembler, that is the machine language instructions and data to be loaded into the memory, and its corresponding assigned locations address also. Then transfer record or end record will be containing the starting address of the program. That will be the last record in the object program. So it will, once we're done with that, it will transfer the controls to the starting point of the program to initiate our execution. Now we'll start with the first statement. It is, as usual, start. Then second statement, I told you, read the header record or the header card. It is the first card in your object deck or the object program. It will tell the program length and the name of your program. So we can verify the program name and length. Okay. So after that, after reading the header record, read the project object program name and program length. It will be in the header record. After that, read the next card from the object program and check whether if it is a text card or transfer card. If it is a text card, means what? It will be containing the machine language instructions and data, and store those data and instructions to the address specified in the text card. I told you the structure of the text card. Then if it is not a text card, if it is a transfer card, then it will be transfer card or end card. That means what? We have successfully loaded everything, and the transfer card will tell what is the beginning or the starting address of the program. So transfer the control to the first line of the program if it is a transfer card. So first read the header record from the object program. It will be telling the program name and the total length of the program. Then after that, read the next card from the object deck or object program. Check whether it is a text card. If it is a text card, it will be containing output of the assembler, that is the machine language instructions and data, and load into the corresponding address specified in the text card. Then if it is not a text card, then it will be the end card or transfer card. In the if it is a transfer card, you have to transfer the control to the first line of the program. That means we can initiate the program. Then statement 5 means what? Whatever data we are writing in the object deck, it will be in the character format. So we have header record, we have transfer text record, and we have transfer record or end record, right? So here, whatever data in the cards will be available in code character format. But when we are storing the data into the memory, it has to be in the internal representation, that is hexadecimal representation. So convert the character representation in the cards to hexadecimal format. So we have done with the one object program, loaded with the one object program. Once we're done with the one object program loading into the memory, read the next object program. Like that, it will repeat and you can end. I'll repeat again. This algorithm says how an absolute loader read cards from the object decks and store into the memory. Each object deck or object program will be containing 3 records. The first, it will be containing header record, then it will be containing text card or a text record, then it will be containing end record or transfer card. Okay, so first we have to check the read the header record, that is the first card in the object deck. Header record will be containing the name of the object program and total length of the object program. Read that. After that, read the next card from the object deck and check what type of card it is. If it is a text card, which means it is containing the assembled instructions, that is output of the assembler, and store that output into the memory to the address specified in the text card, which I have already shown in the format. And if it is a transferred card or end record, which means we have reached the last line of the object program, so we have stored all the instructions into the memory. Now we can transfer the control to the first line of our program. It will be stored in the transfer card. Okay, then that's all. After that, codes always will be in the character form in the object deck, but when we are storing the data in the object deck into memory, it has to be in hexadecimal format. So convert character form data into hexadecimal format. So that is done with the one object program loading. Like that, read the next object program and repeat the same steps. Thank you. Thank you, everyone. That's all about the absolute loader. We will discuss about the next loader in the next class. Thanks for listening.